These are all just different ways to represent a relation. So we have our mapping diagram and we have an XY table. And what they're doing is they're relating an input value with an output value. And that's why it's called a relation. By simply putting an input with an output, you have created a relation. Okay? So not only can I write my relation like -3 maps to 4, I could just write it as an ordered pair, 3, 4. And that's most of the time how you're used to seeing a relation, just simply as an ordered pair. Now, what I want to talk about with those ordered pairs is that we know it's called an ordered pair. It's called an ordered pair because it's an alphabetically ordered. In alphabetical order, X before Y, right? Okay. The same is true for inputs and outputs. They too are an ordered pair, and they too are alphabetical. It's kind of nice. The same is true for domain and range. Domain and range is just another way to say, hey, domain are all of the inputs or all of the X values. All right? All of the X values that work. And the range is simply all the outputs or all the Y values that you get out. The nice thing is everything's alphabetical. So it's a great way to help keep things straight. All right, domain before range, D before R. Okay, so domain is all the X values or all the inputs, and range is all the outputs or Y values. So here we have our mapping diagram. So I'm asking you first, identify the domain and range. So what is the domain for this letter A? -3 and -1 and 2. Sure. Right there, those are the domain values, the input values. And D for domain, I'm always going to use big D for domain. Sometimes you might see in the book curly braces around them. That's just set notation. It just means all of these make up the domain. Okay. All right. What is the range? 4, 0, 1, and -2. Yeah, all of these output values make up the range. And whether you put them in curly brackets or not is not important. Okay. Well, that was the easy part. So I'm going to go ahead and just do the same thing over here for letter B. What's the domain for letter B? -1, 0, 1, 2, and 3. Good. And what's the range for letter B? The bottom row. Yeah. 5. Do I have to write 5, 5, 5, 5, 5? No. Once is absolutely enough. Okay? You don't have to be repetitive. We don't like that in math. Okay. So easy domain and range. So now we want to determine whether the relation is a function. And function is a key word that we're going to talk about all year long. A function will pass the vertical line test. You should write that down. A function will pass the vertical line test. The easiest way to figure out if our relation is a function is to graph it out. So my favorite saying in this class is, when in doubt, graph it out. That is my favorite saying, and we're going to use that all the time. And that'll also save your butt on a couple of tests in this class. Especially if you have a graphing calculator, you can graph it and answer the question without doing any work, really. So when in doubt, graph it out is what we're going to do. So I'm going to go ahead and just make what I lovingly call a chicken scratch graph. So I'm just going to make a little XY coordinate plane and just do 1, 2, 3, 4, 5 little tick marks. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is what I call a chicken scratch graph. You see the chicken scratches? Yeah, okay. So real easy, real fast, and it's a great quick tool to figure out if something is a function. And what we're going to do is we're going to plot each of our relations here. So my first relation says -3 outputs of 4. So that's the ordered pair -3, 4. How do you graph -3, 4? 3 to the left. Yeah, we go to the x-axis, we go to -3, and then we go up 4 for the y. 1, 2, 3, up 4. So there's the first ordered pair. What's the next relation we're going to graph? -1, 0, which says go to -1 on the x-axis and up 0, up or down 0. What's the next relation? Or what else goes with -1? -1, -2. -1, -2 is another relation we want to graph. So -1 on the x-axis and then down 2 to get the -2. Then I have 2, 1 for an ordered pair, 2, 1. 2 on the x, up 1 for the y. And that's it. Okay. So what do you notice about those ordered pairs, those relations? So in order to figure out the answer to the question, determine whether the relation is a function. To be a function, it will pass the vertical line test. Have you heard that before? Yeah, a little bit, little bells ringing. So vertical line test says if I draw a vertical line, it's only going to intersect my points or my graphs one time. So do you see a problem? Right here, what do you notice about those points? They're stacked on top of one another. Okay, we've got one on top and one on bottom. And because they're stacked vertically, that makes it not a function. It fails the vertical line test. Okay, so that is the second answer that we're looking for this question. Not a function. It fails the vertical line test. Fails vertical line test. All right, I'm going to do that for letter B as well because I want to be sure whether it's a function or not. I'm going to, again, make my little chicken scratch graph. It's good. My little chicken scratch graph. And what's one of the ordered pairs I'm going to graph? -1, 5 right there. -1 for the x, 5 for the y. So on the x-axis, -1, up 1, 2, 3, 4, 5. We're right there. What's another ordered pair? 0 on the x, 5 for the y. What's the next ordered pair? 1, 5. 2 on the x, 5 for y. 3 on the x, 5 for y. Is this relation a function? Yes, it's a function. Why? It passes the vertical line test, yes. Passes vertical line test. Meaning if I draw little vertical lines, it doesn't intersect them more than once. Nothing is stacked on top of one another, okay? So the vertical line test is super, super duper easy. I could actually give you the definition of a function, but I hate the definition. I find it incredibly confusing. And so I really don't even talk about it because I think vertical line test is so nice and visual. Yes, Olivia.
So I have like two kind of different questions. So is it automatically always not a function if there's 2 points that are horizontal?
Horizontal or vertical?
Yeah, like that.
So if 2 points are vertical, stacked on top of one another, it is absolutely not a function.
Okay, and then if they're all lined up like they are in the second one, if there's just like one that's different, does that make it a function?
Yeah. So if you mean like over here? If there's a point here?
Yeah.
Okay. If there's a point here, still a function.
Okay.
Still passes the vertical line test. If I had a point here and then the point directly below it, that would fail because now 2 points are stacked.
Okay, so it's always a function as long as
If it passes the vertical line test, yeah. If nothing is stacked on top of one another, it's a function. Good question. All right, example 2, graph the function. Example 2, graph the function. We are going to spend a lot of time graphing lines. You will get very good at it. We will review a bunch of different ways that you're allowed to graph lines, but we're going to start today just the very simple way. And for many of you, it's creating an XY chart, an XY table, a T-chart sometimes called, okay? Meaning you're going to pick values for X and figure out what the output will be, okay? I'm going to do it a slightly different way. You'll notice this is kind of an interesting notation. In your book, you're going to see an equation more like y equals 3x minus 4. So that's what you're going to see in your book. And what I'd like you to do is I'm going to use this notation. This is called function notation. How many of you have seen function notation before? Yes. Okay. So yeah, here and there. Okay. So we want to get used to function notation because in higher math we use function notation all the time. So the problems in your book, you're going to see y equals. I want you to replace it with this notation. This notation we read f of x. Okay, that's how you would say it out loud. F of x. The f could be any letter. We could see equations that say g of x, or h of x, or j of x. So that f could be really any letter. And x is just whatever letter you see in your equation. Okay, so that could be a different letter too, but we use x most of the time. Now, we use function notation because it helps us see an input and an output really easily. And so one way is to create just a table of values where you plug in numbers for x and figure out what is the corresponding y value. So that's one option. I'm going to just get you used to function notation today. So in order to graph the function, to graph any function, we just need ordered pairs, right? And we can plot those ordered pairs and connect the dots. That's graphing. So I want to start by finding f of 0. F of 0. What this means is you'll notice we had the f. What's no longer there? The x is no longer there, right? It's a literal thing. It's telling you in place of x, put a 0. That's literally what it says. In place of an x, you're going to plug in a 0. So I'm going to take my equation, 3, and then in place of this x, what am I plugging in? A 0. And don't forget the subtraction. What is 3 times 0? 0. Minus 4 is negative 4. And so what I've done here is we have f of 0 equals negative 4. This is really useful notation, and it is just notation. Do you have to divide off that 0? Isolate f? No. We are not solving an equation. We are not solving for f. We're not isolating f. It's just notation. And what it says is that we had an input of 0 and we had an output of negative 4, which means we have an ordered pair, 0, negative 4. And that ordered pair is something I can graph, okay? So I'm going to do it again. What's another value I could plug in place of x? 1. 1 is a great number to plug in place of x. So again, I'm going to go back to my equation. I have 3 times some x value minus 4. And what am I going to put in place of that x? A 1. And I can just simply do a little bit of cleanup here. 3 times 1? 3. 3 minus 4? Negative 1. And so I see f of 1 equals negative 1. So we had an input of 1. I plugged in a 1. And what did I get out? Yeah, so 1, negative 1 is another point that I can graph. Seems like a lot of work, but I bet you can do this in your head. Okay? How many points, according to geometry, how many points determine a line? 2 points determine a line. And so we have 2 points. Chicken scratch graph. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. I can plot these points. 0, negative 4. 0 on the x-axis. 1, 2, 3, 4 down. 0, negative 4. And then 1 on the x, down 1 for y. 1, negative 1. So there's my 2 points. And I can connect those with a lovely little line there. This is called a linear function. How do you know something is linear? What's the root of the word linear? Line. How about that? This is a straight line function. It is a linear function. The other reason I know it's a linear function is because it's x to the first power. We see 3 times x to the first power right there. And that is a big clue that this is a line. Okay, a straight line. All right. I want to try letter B. Same thing. Your book would show a y here. Y equals negative 2/3 x plus 6. Y and f of x mean the same thing. I'm just using function notation because that's actually the next question as well. So I just want you to be used to it. What can we plug in for x? 0. 0 and 1 are excellent choices. They work really, really well. So I'm going to plug in a 0. So negative 2/3. And then in place of my x value, what are we doing? 0. Wherever you see an x, you put a 0. Wherever you see an x, you put in a 0. What is 2/3 times 0? 0. And so we just get 6. So f of 0 equals 6. What does that mean, f of 0 equals 6? 0, 6 is an ordered pair. Very good. 0, 6 is an ordered pair that we can graph really easily. All right, what's another number I can plug in for x? 1. Sure, it's a great number to plug in for x. There's even a more strategic number, but I'll talk about that later. Negative 2/3. It would be 3. That's a very strategic number to plug in. And what am I plugging in place of x this time? A 1. What is negative 2/3 times 1? Yeah. Negative 2/3. Negative 2/3 plus 6. Too much math in the morning. Yeah. It is 5 1/3. Yes. It is 5 1/3. How do you do that mathematically? What do we need in order to add fractions together? Common denominator. So I'm going to put that 6 over 1. What do I need to multiply by? 3 on top and bottom. So that becomes negative 2/3 plus, what's 6 times 3? 18/3. What is 18 over 3? Back to 6, right? 18/3 is the same as 6. Okay, so now we have negative 2/3 plus 18/3 is what? 16/3. 16/3 is totally weird to graph. Totally weird to graph, so I want to change that to a mixed number. How many times does 3 go into 16? 5 times, that makes 15, which is 1 away. So 5 1/3. So we have an ordered pair 1, and 5, and just a little bit to graph. And I can do that, make a little chicken scratch graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So again, I'm just plotting my points. 0 up 6. And then 1 up 5. And a tiny little bit. A little past 5, and then I can connect those with the dot. What kind of function is it? Linear. This is a linear function because it equals a line. It is a straight line. And it's also because we have that x to the first power is really the key there. We know that's what makes it linear. And if you didn't know that, now you do. All right. Questions on that? Looks complicated, but there's lots of ways to do it. We only have 2, 3 of them. We'll do the quick graphing later. All right, last thing. Example 3, decide if the function is linear. Example 3, decide if the function is linear. Again, writing example and directions, please. Decide if the function is linear. Then evaluate the function for the given value of x. Bless you. Evaluate the function for the given value of x. Again, when you're doing your homework, there's a few problems that are a little bit weird. Read the directions, okay? But by and large, my directions match exactly what you need to do. Olivia. Not today. I want you to get it done. Okay. So the very first thing, I have my little function here, f of x equals 3x minus 11. So there's my function. Ladies and gentlemen, is it linear? Couple ways you could find out. You could graph it. If you have a graphing calculator, you can graph it and see if it's a line or not. That's one. But the easy way is to look at the power. What power is on x? 1. Right there. It's x to the first power. Because it's to the first power, it's linear. It is linear because it's x to the first power. So easy to see. Right off the bat, it's linear. It will graph and it will be a line. Okay? All right, so then the second part. What does this mean, f of negative 1? What's that telling you to do? Plug in negative 1. Take your function and plug in negative 1. Wherever you see an x, you're going to plug in a negative 1. So I'm going to just take my little 3x minus 11, and I'm not going to write x. What am I plugging in place of x? A negative 1. What is 3 times negative 1? Negative 3. Negative 3 minus 11? Negative 14. F of negative 1 equals negative 14. Do I need to divide by negative 1? No. It's just notation. You're just evaluating, not solving. You're just simplifying the right-hand side. That's all you're doing. Okay? Letter B. F of x equals negative 2x squared plus 3. Is it linear or not linear? Not linear. How do you know it's not linear? Yeah, it's right there. It's x being squared. Does anyone know what shape that is? The parabola. Yeah. The parabola U type shape. Very good. But linear, we're looking for x to the first, not linear, anything else. Okay. And then what are we supposed to do with this f of 5? Plug in what? Plug in 5. That's exactly what that means. I want you to get really used to that. You're taking your function and not using x. Instead of x, we're using that 5. That's what it tells us. Don't use an x, use a 5. Now, here's where order of operations becomes very important. What should you do first? Exponent. Yeah, we have to do order of operations, PEMDAS. So we don't have an operation inside the parentheses, so we move to exponent. What is 5 squared? 25. 5 times 5 is 25. And then what does this mean when I have a negative 2 right out in front? Multiplication. It's negative 2 times 25, which that's what we're going to do next. Negative 2 times 25, negative 50, plus 3, negative 47. Very good. 50 negatives, 3 positives. All right. Do you have questions for me, ladies and gentlemen? All right. So please keep your notes available and use them on the class practice.